Every time you add a new set of reagents, you're adding 7 or 8 new reactions every single time. The reactions multiply. For many students, the carbonyl unit is one of the more difficult units in the course. Let me see if I can explain why and give you some perspective that will help you succeed. Each unit in organic chemistry has its own specific set of challenges. The very first unit, you are probably focused on naming, on resonance, on RNS, and all these new concepts that you've never heard before. In the SN1 and SN2 and E1 and E2 unit, you were probably focused on figuring out which of the mechanisms was even at play. Each unit provides its own set of challenges. For most of the chapters in this course, we learn reactions additively. What do I mean by that? I mean, when you're in the alkenes chapter, you learn a reaction of an alkene. It's a fantastic reaction. When you're done with that reaction, you learn the next reaction. You add one more to the list. When you're done with that one, you add one more to the list. When you're done with that one, you add one more to the list. And you keep adding reactions to your list, each one relatively independent of each other. Sure, they all have similarities. They all have reasons why the mechanisms are similar, but you're adding one reaction to your list each time. The big reason I think the carbonyl unit is such a challenge for students is because in this unit we are learning reactions multiplicatively. What do I mean by that? What I mean by that is when you learn one reaction, say the lithium aluminum hydride reduction of an aldehyde, you're not really learning one reaction, you're really learning the reaction for all of the carbonyl functional groups because they all essentially react the same way. The mechanisms are all essentially the same for each of the carbonyl functional groups. This is what I mean by learning reactions multiplicatively. When you learn one set of reagents, you're really learning 7 or 8 reactions simultaneously. And every time you add a new set of reagents, you're adding 7 or 8 new reactions every single time. The reactions multiply rather than add down a list. Other examples of this include the Grignard reaction. When you learn one Grignard reaction, you've pretty much learned them all. The same nucleophiles can react with most of the carbonyl derivatives without really much change in the mechanism. So with carbonyls, instead of thinking of adding one reaction to your list every time, we're really creating a grid of reactions. I don't think you can probably read this very well. Don't worry, that's not the point. Across the top, we have all the carbonyl-containing functional groups, and along the side, we have the reagents that we learn in this unit. This isn't even all of the reagents we learn in this unit. But every time we learn a reagent, we learn how it reacts with all of the carbonyl functional groups. When we go to the next one, we learn how it reacts with all the carbonyl functional groups, and so on and so on. We're learning reactions multiplicatively, filling in this grid as we go through the unit. Now, this isn't a perfect analogy. For one thing, not every reagent reacts with every single carbonyl functional group. Some reagents don't react with some carbonyls. We'll have to figure that out as we go. Also, when we learn the reactions of one set of reagents, sometimes there are exceptions to the rule. We see that with the lithium aluminum hydride reaction. For lithium aluminum hydride, it reacts with the carbonyl functional groups to make alcohols, except when it reacts with amides. When it reacts with amides, it makes an amine as the product, and that has to do with nitrogen minus not being a very good leaving group. That's not the point of this video. The point of this video is this multiplicative nature of learning the carbonyl mechanisms. This, I think, is why the carbonyl unit is so tricky, because we're learning dozens of reactions in a very short period of time. If you can keep that in mind, though, and if you can recall that these reactions are really very similar, then I think you'll do a little bit better with this unit. Know that we're learning things multiplicatively, and know that the mechanisms are more or less the same, and know that when you learn one, you're really learning 7 or 8, and that will help you get a grasp on what you're learning and help you have a better time succeeding in this unit.
Thanks for training with us today, Ninjas. Check out this other content to see if you can level up even further. As always, don't forget to like and subscribe.